So for us to be able to break apart a non-factored polynomial, we are going to need to have to remember how to do some division. So if you have not done long division or synthetic division in a while, I wanted to go over those rules. So this should be something that you did last year in Algebra 2. But let's go over the rules and pretend like we've forgotten. If we want to divide using long division, let's just for a moment, now I know it's going to be silly, but it's going to help us, I think. Let's say that we want to divide 74 divided by 6, okay? So if that was our given problem, and we wanted to do it using long division, remember your dividend, that's the 74, the thing that comes before the division symbol, goes inside the box. The divisor, the thing after the division symbol, goes outside the box, okay? And then remember, you know, I know this is but it's going to help us, I believe. How many times does 6 go into 7 without going over? Once. So you put the 1 up here. Whatever's on top, remember you're going to multiply. 1 times 6 is 6. You put it underneath, you subtract it. Okay. If you did it right, the number you get when you subtract is less than 6. It's 1. Perfect. Okay. And then the next thing we do is bring down our next digit and do it again. How many times does 6 go into 14 without going over? Twice. Yep, you put it at the top. We're going to multiply. 2 times 6 is 12. Put it under, subtract. This spot, if we do not keep going, is our remainder. And we actually could rewrite that as a fraction. I have 2 out of the 6, which of course can be reduced, but I don't really care about that at the moment. But so I just wanted to talk about how we actually do it with numbers. And then I think it will help us flow a little nicer when we do it with polynomials. Okay, so let's go to number 1. We're going to do it with long division. So inside of our division box is going to be r cubed plus 2r squared minus 7r minus 12. Now, as you put that in your division box, it must be in descending order, and if any power at all is missing, you have to put a 0 in that spot. What do I mean by that? I have a cube, then a squared, then an r, then a number. All of those things in descending order are accounted for. Again, if something is missing, we put a 0. In our numerical system, we have to put zeros there. Like the number 10 is not the number 10 without a 0. In a polynomial, we just don't even put it. So we could have a term that's missing. So put a 0 if a power is missing going from descending order. Now on the outside is our divisor, that r plus 3. Okay. Now we kind of almost think of it like a 2-digit number. That's a good way to think about it. We're going to compare the first thing with our highest power. What would we multiply r by to turn it into r cubed? R squared. So we're going to put that above the squared term. So think about the fact we kind of had to use the second digit, r squared, okay? So you want to put that over the matching power. And then we're going to distribute, but in multiplication, just make sure you distribute or multiply by both things, okay? But we're going to do the same technique we did with the number over here. We're going to multiply and put it underneath. So r squared times r is r cubed. If you did it right, these things right here, right now at that spot should always match because you're trying to make them match. That's your goal. R squared times 3 is positive 3r squared. But think about under here, we were subtracting. Mathematically in algebra, to subtract, we multiply everything by -1. So multiply through by -1. When we do that, the first term, our r cubed, should always go away. It did. Great. Wonderful. The next term usually doesn't, sometimes does, sometimes doesn't. 2r squared minus 3r squared is negative 1r squared. And you can just write that as negative r squared. And just like over here, we brought down that 4, we have to bring down the next term. So we're going to bring down negative 7r. We're going to do the exact process again. What times r would give us negative r squared? We're always comparing the first terms. Well, we need a negative and we need an extra r. So that is our r term that goes above. Now we know we did it right when we distribute if we get that matching thing in the first spot. We don't care about the second spot as much, but that first spot always has to match. Negative r times r is negative r squared. We did it. We matched. Negative r times 3 is negative 3r. But in algebra, when we're subtracting this next piece, we have to multiply by negative 1 or change the signs of both. Negative r squared minus and positive r squared cancel out. Yay. Negative 7r and positive 3r is negative 4r. Bring down r12, negative 12. And our last phase here, what should we multiply r by to get negative 4r? Well, we need a negative 4. And so again, we're going to distribute that to both of those. So it's the same exact procedure for numbers as polynomials, except we have to follow our rules of algebra as we go. Negative 4 times r is negative 4r. Match perfect, yay. Negative 4 times positive 3 is negative 12. So we are subtracting, so we change the sign to both. We get a 0 remainder on this, so we don't have any fractional component up above. So the answer to our division is r squared minus r minus 4. We could check that division. If we were to multiply these two things together, we should get that long polynomial that you see here. So to check a division problem, you can use multiplication. That is an option. Everybody good with problem number 1? Let's do it again. So inside our division box is n cubed plus 5n squared plus 10n plus 6. Check our powers. 3, 2, 1, nothing. Perfect. We are not missing anything. On the outside, n plus 1. We're going to ask ourselves, what would I multiply n by to turn it into an n cubed? That would be n squared, so it's going to go on the above the n squared spot. We're going to distribute to both of those. That's going to be n cubed plus n squared. We are subtracting, so we change the signs of both and combine like terms. N cubed minus n cubed should always cancel out, or you didn't do it right. 5n squared minus n squared is 4n squared. Bring down the next term. So our 10n comes down. Now we're going to do it again. We're going to compare n with 4n squared. What do I multiply n by to get it to be 4n squared? We need a 4 and another n, so it's positive 4n. Put it at the top. We're going to distribute. We get 4n squared plus 4n. But we are subtracting. In algebra, to subtract, just multiply by negative 1. 4n squared minus 4n squared is nothing. That should always happen, or something's wrong. 10n minus 4n, or plus negative 4n, however you want to think about it, is 6n. Bring down that 6. This is our last step when we've brought down the last number or thing. What times n would give us 6n? That would be positive 6. And we're going to go ahead and distribute that positive 6 to both of those. We get 6n plus 6, but we are subtracting, so we're going to change the sign of both. We do have a 0 remainder. Okay. Now let's say we got a remainder of n plus 7. We would just put n plus 7 over n plus 1. You just write it as a fraction of your divisor, just like before when we put that over 6. Same idea. So if we do have a remainder, write it plus that fraction and that's the best way algebraically to write it. Do we have any questions about long division with a binomial, two pieces? Okay. Now, there's only really one technique to do number 11. So you'll notice that it's giant, but we'll take it one step at a time. Now let's just check our powers before we get started. 6, 5, 4, 3, 2, 1, 0. So there's nothing unaccounted for. If there was, put a 0 there. If it's not in the correct order, it should go from 6 down to nothing. If it's not in the correct order, put it in the correct order before you begin, or it will not work. Okay. So I'm going to write inside of my division box my 5x to the 6th minus 16x to the 5th, and so on. So let's rewrite our polynomial. And it's not a bad idea. It's very easy with a long polynomial like this to make a rewrite mistake. Always check your work. And then we also have to check our divisor also goes in descending order. If anything is missing, we would put a 0. There's nothing missing, so we can just write our x squared minus 4x plus 2. Okay. Now, as we go through this process, we are going to be using 3 terms. So this is kind of almost like a 3-digit number. We're going to be using 3 terms at a time. So even though it looks disgusting, it's going to go quick because we're using 3 things at a time, okay? So the first thing you do is compare these two. What would I multiply x squared by to get 5x to the 6th? Well, I need a 5, and I need an x to the 4th. So we're going to put this all the way down to the x to the 4th spot. So you need to notice I use 3 digits to get there, okay? And now I'm going to distribute to all 3 pieces. When I distribute, I get 5x to the 6th minus 20x to the 5th plus 10x to the 4th. But we are subtracting, so change the signs of everything or multiply through by -1. However you want to think about it, it both accomplishes the same sort of thing. Now, 5x to the 6th minus 5x to the 6th is 0. That should always happen with your first term. Negative 16x to the 5th plus 20 is a positive 4x to the 5th. Negative 11 minus 10 is negative 21x to the 4th. We need 3 terms because we started with 3 terms. So we do have to bring down our next term, our plus 22x cubed. Let's do it again. What times x squared would give us 4x to the 5th? Well, we need a 4, and we need 3 more x's. And you'll should notice our work is going downhill as far as our powers go. So we need a 4, and we need 3 more x's. Now let's distribute. 4x cubed times x squared is 4x to the 5th. Those first ones should always match, or you didn't do it right. 4x cubed times negative 4x cubed is negative 16x to the 4th. 4x cubed times 2 is positive 8x cubed. But we are subtracting. To subtract in algebra, we multiply through by -1. So this is going to be a negative, a positive, and a negative. Now we're ready to combine like terms. 4x to the 5th minus 4x to the 5th. That first term should go away. Yay. Negative 21 plus 16 is negative 5. So that's negative 5x to the 4th. 22 minus 8 is negative 16. We need 3 terms, so bring down the next one. You'll notice we only got 2 more steps left because there's only, we have 3 more steps left because we do have those things left. 22 minus 8 is not 16, is it? I saw the faces. I know when I make a mistake. Would 14 be a little better? Everything else look good? We make one mistake on this, you know, okay. So now we have to compare our first ones here. X squared, what do we multiply to get negative 5x to the 4th? That would be a negative 5 and 2 more x's. You can see I'm above the x squared term, so that's good. We're going to distribute we're going to get negative 5x to the fourth, positive 20x to the third, minus 10x squared. But we are subtracting, so change the signs of all the terms. And now we are ready to combine the like terms. And so our first terms go away. Yay, we did it right, hopefully. Minus 34x cubed plus 24x squared. Bring down our next term. Oh, we're getting close. Okay. Do it again. What times x squared would give me negative 34x cubed? Well, I need a negative 34x. This is getting gross, isn't it? We're definitely going to have, I think, a remainder when we're done. Maybe not. Okay. Negative 34x times negative x squared, or positive x squared, is negative 34x cubed. 34 times 4 is 120, positive 136 x squared. Let's see here. Negative 34 times positive 2 is negative 68x. We are subtracting, so we are going to change the signs of each. Did I do my multiplication okay? Does that seem legit? Okay, so our 34x's went away. 24 minus 136 is negative 112. 68 minus 4 is positive 64. And the last thing we have to bring down is a 9. And then what times x squared will give me negative 112 is negative 112. Sorry, I don't know why I changed color all of a sudden. But okay, so let's distribute. When we distribute, we get negative 112x squared. Let's see, what is 4 times 112? That would be a positive 448x, and then a negative 224. We are subtracting, so we are going to change the signs of everything. Our 112x squareds go away. 448, negative 448 plus 64 is negative 384. 224 plus 9 is positive 233. That is our remainder. So for the very first time in our gross one, if I haven't made a mistake, we do have a remainder. And let me show you how to write that remainder. What we're going to do is you're just going to put a plus. You're going to put the remainder in parentheses on the top of your fraction. And in the bottom of your fraction, you're going to write the divisor. In this case, it's x squared minus 4x plus 2. Okay. So that nastiness is one we don't do usually a 6th power that often. So usually 4 or 5 is the highest we're going to go. So don't expect that we will have much more than that. Again, any remainder, put a plus, put your remainder on top, and your divisor on the bottom. Okay, so that is long division. It's hard to really describe the process any other way than just kind of jumping in and doing it. But I do want to talk about synthetic division because it is an alternative that I tend to jump in and use when it's in the right situation. Problem 1 and problem 2, we could have used a technique called synthetic division. So I would like to now, at this time, do synthetic division for this problem here that's labeled number 3. To do synthetic division, here's what you have to have. This has to be 2 terms, which it is, and this front number, the n, has to be positive, and it can't have any coefficients on it. You can use synthetic division if that said 2n minus 9, if you divide everything through by 2 for both the divisor and the dividend. If you divide it off any front coefficient, you can use it, but usually then why not just do long division? Anyway, so what you're going to do is you're going to ask yourself, where is your divisor equal to 0? So in this case, n minus 9 equals 0 when n is equal to 9. And you're going to put 9 in a little box. So whatever the 0 of your divisor is, put it in a little box. Okay. Then we're going to check our dividend here. And we're going to check, is it in descending order? If anything's missing, we need a 0. Its powers are going 4, 3, 2, 1, nothing. Perfect. So then you're going to pull out the coefficients exactly as they appear. Okay. So positive 7, negative 68, positive 46, negative 7, and negative 18. And separate them. You're just pulling out the numbers. You're not adding or subtracting those numbers. Now we're setting up a synthetic division box. So we always set up the box the same way. Okay. So put a line between the last 2 digits. So between the first power term and the constant. Okay. Give yourself some space right here because some numbers are going to go there, and put another little line. Now, the first coefficient we pulled out was a 7n to the 4th. So your lead term coefficient, put a little arrow underneath it to remind you to bring it down. Now that's how you set up the box every single time. Now if your Algebra 2 or Algebra 1 teacher showed you synthetic division and they set up their box a little different, I don't care, do your thing. But I'm just showing you how I do it. Okay. So now we're going to do the same multiplication every single time. We're going to multiply, write it down, add them up. Okay, let me show you again. We're going to multiply, write it down, add them up. So we could even put a little plus symbol right there to say that's our addition line. Multiply, write it down, add them up. Let's do it again. Multiply, write it down, add them up. Multiply, write it down, add them up. Multiply, write it down, add them up. This little box holds our remainder. There isn't a remainder. N minus 9 perfectly goes into that long polynomial. It is a factor of our polynomial. Now, our answer, or our stuff started with n's and variables in it. We got to put the variables back on. Use this arrow to remind you that our first highest power does go down by 1. So this spot here, this was an n to the 4th. It's going to go down, and our answer is going to start with an n cubed. And we're just going to go down the list. 3, 2, 1. Yeah. Okay. So our final answer is 7n cubed minus 5n squared plus 1n. If you put the 1n there, it's good. You feel free. You do you. And then plus 2. That is the answer. How could we check our work? Well, if we multiply this and put this in parentheses and distribute and did the multiplication, you better get that dividend there. Okay. Let's go back up now. You don't have to do this, but I'm going to erase mine for number 1. Well, I'm just going to make it teeny tiny over on the side. I am going to redo problem number 1. I am going to use synthetic division. Why are you doing that? Stop doing that. I'm not sure why it's not shrinking slightly for me. Anyway, okay, I'm going to do it right here. Okay, so where does r plus 3 equals 0? R at -3. I'm going to put -3 in the corner box. I check my powers, all are accounted for. I'm going to pull out the coefficients. 1, 2, -7, -12. I'm going to set up my box. I put my little bar at the right to separate my remainder. I put my little addition bar, bring down the first thing. Okay. So that's the box that goes with problem number 1. Now, if synthetic division works, we should get the same exact answer we got before, which we're going to. We're going to multiply. Write it down. Add them up. Multiply. Write it down. Add them up. Multiply. Write it down. Add them up. Remember, we got a 0 remainder the first time we did this problem. That's a good sign. We did get it. Look at our answers. Our coefficients are 1, -1, -4. 1, -1, -4. Put your r's back in. Our final answer is r squared minus r minus 4. So synthetic division, I like it. It's easier. You take out the variables, you use numbers, you put them back in at the end. So I do tend to, if it's a synthetic division option, I do tend to go that way. But please make sure you're practicing both. Can you do both? Okay. Okay. So now let's talk about the factor theorem, or the roots theorem, or the zero theorem. Okay. To quick check if a factor divides evenly, if x minus n is a factor, then f of n is equal to 0 because n is a 0 or a root. Let me say that again. If x minus n will divide evenly into a polynomial, then f of n has to be a 0. And that's kind of what synthetic division is built upon. You know how we set that equal to 0 and we solved that x was equal to n, and I said n goes in that corner? Well, if I plug in n, I better get 0 or it's not a factor. So again, to check if a factor divides evenly, a quick check is plug in n. Do you get 0? If you get any other number, it is not this is not a root. Okay. So let's look at the bottom examples. Let's check something out. If I set m minus 8 equal to 0, I get 8. Let's call this function f. If I plug in 8, I get 64 minus 56 minus 11. Which is -3. That's my remainder. That's my remainder. The height of the function at 8 is the remainder if you use division, which I think is so interesting. So if we put 8 in the corner and do synthetic division, okay, so I put 8 in the corner. I pulled out my coefficients, 1, -7, -11. I better get -3 right in that corner. Well, let's do the math. 8 times 1 is 8. Write it down. Add them up. 8 times 1 is 8. Write it down. Add them up. That's my remainder. So we know that m minus 8 is not a factor of m squared minus 7m minus 11. It doesn't go into there evenly. Just like I know that 5 is not a factor of 12. It does not go in there evenly. So if a question asks you, is n minus 8 a factor? You can do division, long or synthetic. That will answer the question. Did you get a remainder? But you can also just plug that into this. Plug in 8. Do I get 0? If I don't get 0, it's not a factor. Let's do number 2. Let's do number 2. N minus 6 equals 0 at 6. Let's plug in 6 into our function. That's going to be 36 minus 6 minus 29, which is 1. It's not a factor. That's our remainder. So if the question in iMath or for me said, is n minus 6 a factor of that polynomial? You could say, nope, it's not going to go in. If I do division, I'm going to get a remainder of 1. Let's do the division to check that we're right. Well, we're going to put 6 in the corner. 1 minus 29. Make your division box. It's a perfect candidate for synthetic division. We're going to multiply, write it down, add them up. Multiply, write it down, add them up. Oh, what did we predict our remainder was going to be? 1. What did we get our remainder was going to be? 1. What's the answer to the division? Well, it's really n minus 5 plus 1 over n minus 6. Not nice. It didn't come out evenly. So it's almost n minus 5, but n minus 5 times n minus 6 needs a 30 on the end, not a 29. That's why that little extra 1 came out. Okay? Okay. Now, given that, that leads us to a very important concept, these two problems we see here. Factor each and find all the zeros. 1 0 has been given. Okay. If negative 3 is a 0, I know that x minus a negative 3 will be the factor that's involved. It's always the opposite sign. This factor divides evenly into that. So it is a divisor of that. It goes into it evenly. Now, if we look at our numbers here, we got 4, 3, 2, 1, nothing. We've got 4, 3, 2, 1, nothing. Perfect descending order. So the first thing I got to do is I've got to take out the one they told me. Now you can divide by x plus 3 either way, synthetic or long division. Don't care, pick a way. You do whatever way you like. I'm going to do synthetic division. So I'm going to put that negative 3 in that corner. I'm going to put down my coefficients 4, negative 8, negative 61, 2, and 15. I'm going to make my synthetic division box. Now, it better be a 0 remainder in that corner because they've told me that x plus 3 is a divisor, negative 3 is a 0. If x minus n is a factor, then n is a 0. That's how they go together. You got to know that. Okay, so let's do the multiplication. Multiply, write it down, add them up. Multiply, that is going to be 66. Write it down, add them up. Multiply, write it down, add them up. Wait, did I do something wrong? Yeah, I sure did, didn't I? Okay. Well, I'd made a mistake way back here, which then messes up the entire thing. Okay, anyway. I knew I wasn't getting a 0 there. Okay, how about negative 8 and negative 12 is negative 20? And then we've got 60, and then we've got 1. And then we've got negative 1. We've got 3, we've got 5, We've got negative 15. Oh, we got 0. Oh, because we know it's 0. So it's easy to find when you make a mistake because it ain't going to come out to be a 0. Something's wrong. Okay. Now, we're going to call our resulting function anything but f. I just need a name. Call it what you want. Doesn't matter. Let's put the n's back in. Remember, our power went down by 1, so it's not a 4 anymore. It's a cube. So it's 4n cubed minus 8n squared. Oh, they are x's. Let's put x's on. This is hot. 4x cubed minus 20x squared minus x plus 5. Okay. Now, an interesting fact. We need some more zeros. With a cube, we hope there's 3 more. There might not be. There might be. We're going to use this number to help us. I would check by plugging in numbers that go into 5 evenly. Well, there's not a lot to choose from, right? Positive 1 and negative go into 5. Positive 5 and negative 5. So I really have 4 things to check that will give me nice numbers that go into 5, okay? So I would always check 1, negative 1 first. If you plug in 1, you get 4 minus 20 minus 1 plus 5. That's definitely not 0. Negative 1, not 0. So let's try 5 and negative 5. If you plug in 5, 4 times 5 cubed minus 20 times 5 squared minus 5 plus 5 might do it. Ooh, you plug it in and you get 0. So I have just found that 5 is a 0, so x minus 5 is a factor. I can take that one out. I'm going to do synthetic division again. I'm going to put 5 in the corner this time of my result right there. 4, negative 20, negative 1, and 5. And I'm going to do it again. Better get 0 right here. Something's wrong. 5 times 4 is 20. Write it down. Add them up. 5 times 0 is 0. Write it down. Add them up. 5 times negative 1 is negative 5. I got 0. Yay. Now, at this point, I got a new factor. I'm going to call it k of x. I don't know. And that's going to be 4x squared minus 1. I need the factors that are living in that. But that is a perfectly lovely thing that's factorable. Squares are factorable, or you can use the quadratic formula to find those zeros. So that factors to be 2x plus 1 and 2x minus 1. Just take the square roots of each. Okay. So let's go back to our original function. What have we taken out? Well, we divided out an x plus 3. We divided out an x minus 5. And then we have 2x plus 1 and 2x minus 1. Okay, so that's what we've got. That is in factored form, which gives us all of the zeros nicely. 1 was negative 3. 1 was 5. Now think about if you solve that, you would have to subtract 1 and divide by 2. So that's actually the fraction, negative 1 over 2. This is the fraction, positive 1 over 2. Now you can set that, if you do 2x minus 1 equals 0, you get 2x equals 1 and x equals 1/2. But this will always be your denominator. This will always change sign and be your numerator. So 1 over 2 is what I got. So this is very powerful stuff. Think about how easy now this is to graph. I hit the x-axis at negative 3, negative 1/2, positive 1/2, and 5. This end goes up, got to go through, got to go through, got to go through, got to go through. This end goes up. I know what the graph looks like. I don't know what this graph looks like. I know that the both ends go up when I see that. I don't know. Because that's how powerful knowing how to get it into factored form or knowing what the zeros are. The factors give us the zeros, the zeros give us the factors. They go together. Okay. Let's do number 4. They have told us that 2 is a 0, so x minus 2 is a factor. Got to divide it out. You decide, do I want to divide it out using synthetic or long division? I jump to synthetic when all possible. So I'm going to put a 2 in the corner. I'm going to check my powers. 4, 3, 2, 1, nothing. Our polynomial is in perfect descending order. No terms are missing. If it is, put a 0. So I'm going to have 3, 6, negative 23, 2, and negative 8. I'm going to set up my box. I know I have to get 0 in that corner because 2 is a 0. Okay, what do we get? Multiply, write it down, add them up. Multiply, write it down, add them up. Multiply, write it down, add them up. Multiply, write it down. Yay, we got it. So now we have broken it to our next step. Give it any other letter you want. Don't care. Pick a letter. I'm going to go with H. This is 3x cubed plus 12x squared plus x plus 4. What am I going to try next? How do I find a 0? Well, 4 comes into play. We're going to talk a little bit more about finding the zeros, I think, tomorrow. But I would definitely try in numbers that go into 4 evenly. That's a list. I can try 1 and negative 1, 2 and negative 2, 4 and negative 4. If those don't work, this 3 here can create fractions where I think it is, this is our denominator and this is our numerator. So 1/3, 4/3 are options too. But I avoid those at all costs until the end. I'm hoping that something kind of shows itself. Now, even though we tried to once, that doesn't mean it's not a factor again. It goes into 4 evenly. So I do always rule that out kind of as our first step. So let's just rule out that there isn't a repeat factor at 2. There's not a bounce there because that squared is a possibility. I don't, if all of these are positive, am I ever going to get 0 if I plug in 2? Think about it. If I plug in 2 right now, aren't I going to get a positive big number of some sort? So that one's out. That's not going to equal 0. So that kind of tells me when they're all positive, I need a negative to kind of bounce things back and forth. So let's try now negative 2. If that doesn't occur to you, try 2. It's going to be a big number. But if we plug in negative 2, we get 3 times negative 8 plus 12 times 4 minus 2 plus 4, which is 26. Oh, nope. Let's plug in another negative. Let's try negative 1. I get negative 3. Negative 3 plus 12 minus 1 plus 4. Not enough. It's 12. It's still positive. So then I'm going to try negative 4. Again, trying in positive 4 is a fact. I'm trying to narrow things down. So if I plug in negative 4, 3 times negative 4 cubed plus 12 times 16 minus 4 plus 4. Oh, that's a possibility. Oh, we found one. So that means that x plus 4 is my factor. It's always the opposite of the 0. Okay, so now I'm going to divide by putting negative 4 in the corner of this junk right here. So write down your 3, 12, 1, and 4. We're using that H this time. Make your box. Let's do our math. Negative 4 times 3 is negative 12. We get 0. Negative 4 times 0 is 0. We get 1. Negative 4 times 1 is negative 4. We better get 0 in the corner. Yay, we did. Okay. So our, what do we call this one? K. Our k of x this time is 3x squared plus 1, which is not factorable. Now, how does Mrs. Haught know that? We know how to factor the difference of squares. We don't know how to factor the sum of squares. If you put it into the quadratic form, you get an I. That's called an irreducible quadratic. It can't be reduced further. There are no zeros. It's always higher than 0. It's 1 or higher. So it's not factorable. But let's look at our original form. We took out an x minus 2 and an x plus 4. We were left with this thing that doesn't factorable and is not broken down. So our zeros are at 2 and negative 4. So the only place this particular function hits our x-axis is at 2 and negative 4. And you could take these functions and throw them into Desmos. You could see that it only hits it twice. Just because the power is a 4 doesn't mean it hits it 4 places or there are 4 zeros. That is the most zeros we can ever have, but you might have less depending on the structure of the function. Okay, so turn this in, please.